Hmm. Hmm. What's the first? I want to copy this out. That's rotated this way and paste it in 3D.
First do Z negative 90.
Z. Why do I have to do Z first?
It's on the bottom left corner over there.
Yeah. Why do I have to? What do I have to do to this?
Rotate it 90 degrees from the way we're looking at it. Clockwise.
Why?
To get the, you can work on the XY axis as our work surface.
So I need to exactly that. Need to get this aligned with that elevation, right? So I need to take here. Right. This is X. If we look at it like this, X, Y, Z, right? We need to get like that. Otherwise, when we copy this elevation out, it would be It would be 90 degrees the wrong way, counterclockwise. So the first thing I do is UCS Z, and then I want to go. Which way do I want to go? Clockwise. So what does that mean in AutoCAD? Negative, right? So we want to go negative 90. All right. So now X and Y is in line with that elevation. So right, if I type in plan, we know we have this elevation in the right orientation. I assume you guys are doing this as you're drawing these, I hope. It does help, right? Drawing upside down doesn't make the most sense. So as you guys sort of work on these elevations, you can sort of flip the UCS, right, as you go. And if we have 45s, we can deal with 45s, right? Or if we don't have 45s, what do we use to quickly align?
UCS entity.
Right? UCSE, remember? Okay. What's that? UCSE aligns the UCS to a pre-existing line, which we can see there's a problem with the drawing, but it's all right. Like in plan, that's why UCSE is important for these odd angles, so we go always perpendicular, right? So this is skewed right now, right? Like it's off angle. Okay. What do I do next? Yeah, so I have to select what I want to copy, right? And then I can right-click, clipboard, copy with base point. And then I pick, in this case, that corner, right? Does that make sense so far? Okay. So select what I want. And be careful when you select what you don't want. And then we can right-click, clipboard, copy to base point. And then pick our base point. What do I do next? UCS X90, right? So before we do this, I always like to actually be in a 3D view, right? And this one puts us in an odd one because we already rotated it. So if we go to UCS World and then actually go to sort of an isometric view, we can work a little better, right? So we always have to adjust the view before we flip the UCS, because if we do it after, our view cube that we've been using to alter the view is reorientated, right? And that really confuses us. So now we need to go through a couple of processes. So we do UCS. I can go Z negative 90 again, put us in that position, and then UCS X90, right? So now I have my UCS aligned to the proper interior elevation. What do I do next? So we can go back to our clipboard, and this is where we paste as a block. So we didn't talk so much about blocks. I mean, we've been using them in this sort of technique. But the idea is that we can take this bring it as a block, and then insert it to where we want it in the elevation. Yeah, it's not joining it, it's turning it into a block. You're saying it's doing it even when you paste it? I think by standard it does it even though you're not selecting block. As a paste command, it's assuming it wants to be a block. Yeah. Yeah, so we have to eventually edit the block and then do that. Yeah, because it's grouped as sort of one item. So you have to sort of edit the block and then assign the block. So we're going to do that today. Okay? So you guys were exploding it from here, right? And then doing the extrusions. Or some of you are even drawing over this, right? So like adding 3D layers for 3D. So what we'll do next is let's just look at the question you guys had about using the elevation, okay? Where we can control it by turning it on and off and then drawing right on it. So although we're using one layer right now, which I'm not even sure, I'm assuming it's probably, in this case, 0. And then it looks like we have some line weights starting, light and medium. We can produce a specific layer for the block. Okay? So we can make, so if I assume that that is an interior east, so we can say east block, right? And then we can pick this, and then we can switch this to an east block. That will allow us to turn that elevation on and off, regardless of what the line weights are in it. Okay? So you can't do sub. This is like burying a layer within a block that's controlled by a layer of the block. I don't know if that makes sense. So if we're, if we have all these layers, right? And, we talked about this like not being like Photoshop, right? These sort of layers don't sort of stack. There's no hierarchy, although there is a sort of driven hierarchy in how they've been drawn, like front to back. But ultimately, we can take all these objects that are on different layers, say it's like 1, 2, and 3, and then put the whole block on a new layer. And still keep the line weights. But then this is more of a control of turning that object on and off through a layer. Does that make sense? Okay. So now if I want, so if we quickly do this, and the reason why this becomes important and it becomes also a little problematic is if we have, so I'll go to UCS World again, so I'm down below. I'm going to copy this one now, so I can do a UCS Z90, right? So now my orientation is correct for the west elevation, interior elevation. What's north? Or so right now yeah, no, it's okay. I'm using X and Y. So again, if we're drawing from,
You're using X as you're rotating it around X.
I'm rotating around Z. So every time I type in like UCS Z, I'm rotating about.
The image, are you trying to rotate?
I'm always drawing in X and Y, right? So our drafting table is laying X and Y, and Z is always up, right? So if I need to orientate my drafting table to an elevation, I would need to rotate about Z 90. So that way Y and X are going in this direction. So X is always sort of the front edge of the table, if we're talking about like drafting.
Right, so you're rotating the image on it.
And I'm rotating in this case the paper.
But okay, keep going.
It's all right. So I'm rotating It's as if I'm rotating the table maybe in my drawing stat. You can look at it both ways. But because I'm changing my world is maybe more the table, and the drawing is more the paper in this case.
And you always want to make X where the wall meets the
Yes.
Your hint.
Yeah. Yeah, exactly. So, and I always want, like, as if I would be drawing normally, as the ground line being at closest thing to me in an elevation, right? Where in a floor plan, it doesn't really matter so much. So floor plan orientation might be governed by north, Y up is north, right? Like when we draw a plan, like traditionally on a drafting table, we typically, like, architectural standards are north is up. So for us, north is typically Y, unless we have a building that's on a site that doesn't have a true north sort of orientation. We might alter the north, right?
The floor is on the left, where the wall meets the floor. That's the
When we're dealing with elevations, yes. So that's the X.
That's what I was trying to.
Yeah. So that's why we're spending time flipping this around. So when we copy it and paste it, we're dealing with sort of the bottom condition, right? So if I do UCS, in this case Z90, I'm in the proper orientation for that, right? So X is running this way along the floor. Okay. And then we can come here and do our selection, right click, clipboard, copy with base point, pick that condition. And then we can go into our, let's just get to our world. We can go into our view, right?
What does plan?
Plan just orientates our drawing to the current UCS. So now I can go ahead and go UCS Z90 and then UCX X90, right? So I'm looking from the back side, but my X is here and my Y is going up, so the orientation is correct. So if I right click and clipboard paste as a block, I can paste it there, right? And then I can make a new layer and call it West block. Pick this and then switch this to West block. And then that way, say I want to draw now on that opening. So I assume that's some type of corridor or something. That's hallway. Okay. So if I were to type in plan now, right? Plan, it's going to reorientate my drawing, in this case my drafting table, to the elevation. But I also see the east elevation, which could be confusing. Some people can just work that way. But if we turn it off, turn the right one off, the east one, now we're just dealing with that elevation. So now if I start drawing on there, it makes a little bit more sense. Now the other issue that you might run into is where the UCS is placed in relationship to that. So we might be drawing, and it might not be where we think it is, and this is where it gets sort of funky when we reorientate this. But based on where the position of the UCS icon is, and we haven't really talked about this so much, but we can change the origin. I think it's asking for origin. And actually position it at that position. So I'm just typing in UCS, and then actually locating where we want the UCS to be. Does that make sense? Because the Z, like where we draw now, so if I go back to plan now, nothing will change. But now I know my UCS is actually at that surface position by moving it.
You put coordinates in.
So Z0 now is on the wall. Because otherwise, if you're drawing and Z is over here and you're thinking you're drawing here, this was happening with some of you on the detail. The drawings were, the line work was showing up over
Yeah,
here.
that's kind of what my question was.
Yeah. So we have to reorientate. So that's the tricky part. I was trying to get you guys to do it all flat
Uh-huh.
and then flip it up when it's ready to go. But if you're going to now draw on here, you have to move the UCS. So it's just UCS, and then you can click on a point and then move the UCS to be at that corner.
So now the default, like, drawing position is on the UCS XY.
And Z0,
Unless you click one of the snaps or whatever, it's going to be on that plane.
yeah. And then Z0 is on that plane. Does that make sense, guys? So we can sort of see now our Z0 is right where that surface is. So if I start drawing some type of detailing here, you know, if we assume there might be, I'll just draw over this real quick because it's a block. And this is where it's not bad to just start drawing over with like line weights. So if I offset something and I draw something there, I know it's going in the right position, right? And if it wasn't, if it was just Z somewhere that we didn't really control, it's based off of where Z world 0 is, it would draw it over here, you know, somewhere else. And then we can move it. I mean, it's not a big deal to fix that, but it's one extra step. So if you're going to attempt to add detail after you flipped it up, which might happen with some of you, you need to make sure you're doing that. So again, so when you trigger the UCS, you have the ability to change its origin. So you want to pick a corner and then hit enter to sort of set it. Okay?
It's kind of the same thing as a UCSE.
Sort of. I mean, UCSE can sometimes be problematic because you think it's getting the entity, but the line might be drawn backwards. Like, again, AutoCAD's like the way you draw the line, it has a direction. So if the direction is not from left to right, but from right to left, it might flip it on the back side versus the front side. Does that make sense?
Yeah.
So direction of how you drew is critical as well. So sometimes E becomes a little confusing. So if I just do UCSE, in this case, you know, it's maybe picking the wrong line, right? I think it's picking the line which is part of the floor plan. And if we try to pick the block or another line, it's, you know, so sometimes it does things you don't want it to do. So now it aligned with that line, so it's a little trickier to get it to align where you want it to be. Okay. So far, so good? All right, let's talk about, all right, any questions on this before we start talking about sort of plan versus elevation?
Yeah, is there any way to flip? Do you see how it's kind of like not oriented the right way? Is there any way to flip it like 90 degrees and just, like from this view right here? Is there any way to flip it 90 degrees perfectly?
Like, start to control this thing a little better?
Yeah, because I would always get it like kind of skewed off like 90 degrees the wrong way, and then there's no way to navigate it how I want it.
I mean, the biggest problem with the view cube is like once you have it in this sort of awkward orientation, you typically have to go back to world. You know, UCS world, get where you want to be,
Right, exactly.
and then go back to the UCS. And then sometimes you can do the E, you know. but you know that didn't do it. So sometimes it's better just going through the process. Getting where you want it to be. So it's a lot of sort of flipping and getting to where you want it to be again. And this might actually, I want to be in the other side, right? So I can do UCS Y180, right? Because I might want to be drawing on the inside when I go to plan now. So yeah, it gets tricky with you because you can see now the whole orientation of what's top and what's bottom, what's left is based off of world, right?
Right.
So my front is over there, so it gets, you know, it's hard to coordinate like what view I want to be on. You know,
Because you can
even when you think you have it logically figured out, it won't do it.
Yeah, because when you're looking top down, you get like the rotation little arrows on the view cube.
Mm-hmm.
So you could rotate it 90 degrees, but then once you go to the isometric view, it takes away the arrows, so you can't do that.
Yeah, so you're sort of, and when you think you're getting what you think you should be getting, you don't quite get it. Right? So it becomes awkward to start the maneuver. So unfortunately, going back to world and then understanding getting the view you want, and then getting your UCS where it needs to be. In this case, that. Right. And that's backwards, right? So we had it right before. Actually, that's backward now. So it gets, you know, you have to reposition it. Does this make sense? Yes? No? That was like I had not going this way. What doesn't make sense? You still, I know it's tricky. Until you start doing it. Yeah, I can imagine. Okay. Yeah, it's definitely once you get the aha moment at one point, you know, and you're like, oh, that's pretty, but it does take some tricks or tries.
I don't understand how the Z-axis comes in place because I only use X and Y.
So the Z, if we're working in plan, the Z is always up, right? If we're working in elevation, Z is always out from the wall. All right, so if this is X, so say we're drawing on that wall. This would be X, right? This would be parallel to the ground plane or the ground. Y would be perpendicular, and Z would be coming at you. Does that make sense? So depending on where you're working, you have to sort of get the position right, right? So in this case, coming at you is really going out. So the Z can sometimes be this way or that way. It doesn't really matter.
In this particular drawing, you want the Z to be pointed upwards, why don't you?
Well, if I wanted to work on this elevation, I would want X, Y like that.
Okay, right, but just we're looking at it like we were working on the
Plan.
yeah.
So if I was working on the plan, I'd want Z up.
Okay, like that, yeah.
Yep. So the Z is always sort of wherever your drawing table is, it's coming out of the table. So if you're working on elevation, it needs to be coming out.
Is it necessary to stay in the positive in the positive quadrant?
No,
Why?
no, it doesn't have to. I mean, you're just dealing. I mean, we're typically not adding coordinates, so we're doing our offset commands, or so we're not like adding negative, draw 0, comma 0, negative, comma 10. So it's not, doesn't add that extra complexity. But I mean, we talked about you want to be close to the world 0 though, right? Because that will become other other softwares have other issues, and if we start to migrate them to like Revit or something, the further that we might get away from a 0 position, it could become problematic. Which is hidden in certain softwares, like Revit. Until we see them. Okay, should we talk about elevation versus plan? So we've been doing the extrusions, right? So you guys have, how many people started extruding their walls already? Just 3 of you? So because we're spending a lot of time working on sort of vertical surfaces, we can start to think about extruding these as sort of vertical surfaces that are in elevation, right? So as we did in the detail, if we make a new drawing like we use sort of this 3D drawing, right? And we might call this just wall for right now. And we'll use one of our standard colors. In this case, we'll just use a cyan. Get our UCS orientated. Oops. And then we'll do UCS. All right, so say we're in this position here. So we can trace this wall. And again, why were we tracing these walls? Make sure your layer is current.
Because those are blocks.
Come on, get current. Can't make it current because it's off. Why might we? What's the issue when we start extruding? Yeah, that's one thing, but what? We can't extrude the blocks, so we could explode them, right? So that would be an option. But what else were we dealing? What else happens when we try to make hidden lines out of this? What happens to the line after we extrude it? What's that? Yeah, it disappears, right? So when we extrude this now as a shape, we lose the profile line, right? So if we extrude this and say we do it, we talked about our 5-inch standard, potentially, we start to get some thickness, right? So this is us modeling this in elevation, right? So we take a profile and we extrude it. What's the other option? How else can I make this?
You can do it on the plan, but then you have to rotate 3D.
You can do it on a plan. No, it's more about the plan. We can model it in plan, right? So here it's one component, right? It's sort of one part. What happens? How do we model this in plan?
You just extrude down and then rotate the whole thing.
So that's not really, it's sort of modeling the elevation in plan. But what I'm talking about is we could start to think about, and this will become important eventually, maybe when you guys are working on certain complex sort of trim work or like things where maybe it has a certain profile in plan versus elevation, all right? So let's talk about just making this in plan, and then I'll explain to you why you might want to do it 2 different ways, all right? Like through a detail, all right? Like you guys have been drawing. So if I come here now, I'm going to go ahead and delete this. I want to make this in plan out of 3 parts, right? The sort of sides and then the top. Does that make sense?
You're going to extrude that little square 8 feet up.
Yeah, so I'm going to get back to world where I'm in the plan. And then I might start to think about this wall here and start to build some geometry lines based on a couple things. Sort of the header, which is above, right? And then sort of the two sides that hold that up. So we can use a rectangle command, right? And draw two little rectangles that represent sort of the side condition. And then we can draw the shape that sits on top, right? So I have three profiles now that I can extrude. And I'll first extrude, sorry. I first need to know the distance, right? So I can do a dist command. And of course, it's 81 inches. All right, so let's go with measurements because it came in a little weird. So I'm picking that, and then I'm extruding it up 81 inches. Okay. I could just take this now and copy it. If I want to work a little bit smarter. And then I can take the entire profile and move it up there.
From
1'10".
103 inches from
This
ground to
I
ceiling.
just measured 1'10", but
Well, that might be different.
103 minus 83.
103 minus 81.
well, let's see.
It's 103 inches from the ground to the ceiling.
Let's put 1'10". It's 1'10" there.
23.
So in the end, it's the same result, right? And this is the funny thing. I've been working from the bot. This is like the. Let's get in the right orientation. Pick the wrong button. Okay. So same result, but now we have three parts, right? So that's the difference between sort of extrusion and elevation versus maybe building up something in plan. Where it becomes critical is typically we want to do our walls and elevations, right? So if we have punched openings, those are sort of monolithic continuous surfaces. It's not the end of the world to do this, but if we end up with a detail, so if we come down here and we have some type of detail, like in this case maybe something that's radial, so let's just go ahead and draw an arc, something real fast. Oh, it snapped to something weird. Alright, so say we have some type of profile, which probably would never have like this, but just for demonstration. So if we had something like this that we wanted to extrude, we can't really do this from elevation, right? We can have it drawn in elevation, but it would just be two lines. It would, which is representing the curve, maybe, right?
What's that supposed to be?
That's some type of trim detail. Okay, that we might see, like, say it's this, yeah? Our door jamb. But there's maybe an edge condition here that's curved, or have some type of profile that's curved. And we can't represent that by extruding it in elevation, right? Because we won't get that edge profile. So we need to do it through an extrusion and plan. And then we need to do it, if it wraps all the way around, we'll look at other techniques, but then we might need to take that same profile and understand how to extrude it. In sort of elevation as well, right? Sort of like side elevation. So the difference between, let me just take, I'm just going to draw a P line. Let me erase this line. So if we use our join command, right? And then we do an extrude. try. I didn't spell extrude right. We get this sort of profile, right? So the only way for us to sort of produce that in elevation would be to extrude it from plan. Does that make sense? So certain profiles need to happen this way. Yeah? Makes sense? Where things we typically might think about extruding in elevation, we don't probably want to extrude in plan, right? Like that sort of move is maybe not that good. It's more work, right? It's easier to take the sort of complete profile with the punch openings and setting it back.
How would you do the bottom piece with trim?
So that would be extruded sort of like also in elevation. So if we have some type of base trim, right, which probably you guys have, I don't think anybody lives like in a $5 million contemporary house like by Toyoito. I don't know how much that house costs anymore, but Chicago, maybe someone else. So if it's traditional sort of universal standard, at the ground floor we have some type of trim that's covering, right, where the floor meets the wall, because that's typically in an unfinished condition. So we deal with sort of a base trim and then some type of even nosing to sort of deal with a gap that might be happening there, right?
It's called a nose, like it's like a quarter of a circle.
The quarter rounds, yeah. So it's a quarter round that would happen there as a way to sort of build up the surface to hide the imperfections of those two materials not meeting, right?
Quarter round.
So you have base trim and then a quarter round. Or sometimes you just get base trim. So I think those things need to appear. And similar to the way you guys were drawing your details, right? So some of you guys were doing the woodwork details that have all that intricate form. Those need to somehow be drawn in here so you guys can start to understand how to extrude those. And then we'll look at other techniques to do those as well. Does that make sense? I think the key here is to get as much detail as possible, like sort of zoom in and focus on as you sort of draw your walls. I know unless you have them in your sketchbook right now, they're not going to magically appear, so it's maybe easier to do it while you're there and sort of add that detail and figure out what those things are. But the key is just to start in 2D first, right? And understand it, like maybe true elevation. And then when you have a detail, like some of the people were doing the woodworking details, you have to sort of draw it as a profile and section. And then place it in the right position. And then eventually we'll deal with a sweep command. We haven't talked about sweep. But sweep will allow us to take a profile. So if I draw, let me show you what I'm talking about exactly. Let me make a new layer. So if we make a new layer, let's do that. And just make it yellow for now. So I want to work in section here. So right, I'm in the right position. So now I want to, let's position it there. So I want to draw on that surface. So I'll just sort of freehand. You guys are doing this through measurements, maybe of what your actual detail is. Oh, I lost my UCS, sorry. There we go. So let's draw that again. So let's do a P line. So let's start from here. Let's go out. We'll use that as a guide. Let's just draw there. And then we'll do our oh, did I lose it? Let me just turn up my visual styles. So we can go to our visual styles, bring it back to wireframe so I can see my line work. Okay, I'm just doing this on the fly. So say for some reason we have this strange detail here. Take all these lines, we can join them. So they're one profile. Okay. And then what I can do is start to think about sweeping this. Okay. So what a sweep command does, it allows us to take a profile and then sweep it along a line. So this is maybe the only new command we're introducing today. And let's just do it to here. So I'll turn everything else off so you guys see this. So in the end, we just have this little profile. And then we have this line. So if we type in sweep, first thing it asks, always have to test this. So it asks first for the profile, then it asks us for the line, and we can pick multiples. So let's do that again. Let's join this. So that's a continuous P line. All right. So if I type in sweep, enter, select the object we want to sweep, enter, select the path, enter, it'll sweep it for us. Then if we shade this, we'll get this detail that runs along that path. Okay, so this is how we'll do like crown molding, if you have crown molding, any type of your baseboard molding. And then you guys should be experts at drawing these profiles, right? Based on what you see in the room. Sorry? The corner here, it'll always know how to sort of deal with the corner and sort of, but you know, whatever articulation you have for that detail, you try to replicate. And again, we're not trying to be forensic about it. Like, do the best you can. And that's going to happen by measuring it or look, you know, the actual, you know, artifact in the room. Okay. That's why you know, the sites are your house, right? So it's easy. You have unlimited access potentially, right? Okay. All right, I'm going to stop this